So before we begin with talking about Polito's Home of the Big Slice, I do draw your attention to the middle of this slide where it says that your 4.1 test will be 1 week from today. Okay? We were going to have it after the long break, but we're like, nope, let's get it in before the break. You'll probably do better at it then. We are also going to, the back calendar is not accurate. The formative will be Thursday of this week, and then the test will be on Tuesday. Okay? Just so you are aware. This is your 1 week warning. Okay? So, I need you to find me the perimeter of one slice of Polito's pizza, if it's a 28-inch diameter pizza, and I also would like you to find me the area of the sector of one slice of tasty goodness. Okay? Go for it. Agree with me that that is a piece of pizza from Polito's. Okay. What do we know about said piece of pizza from Polito's? Other than its savory goodness, yes. It's what? Say it loud. Okay, so what does that mean? Okay, so how does that help me with my piece of pizza? So we know that these two sides are 14. Right? Okay. So if you got something that's less than 28 inches for your perimeter, already wrong. It's got just those two sides, right? Okay. What about the missing third side? That's an arc length. Do we have a formula for the arc length? What was it again? Theta? R theta? Okay. What was the kicker with S equals R theta? But what does theta have to be in order to use this one? It's got to be in radians, right? Okay. So now I'm kind of working off of what people were working off of. What was your question? How many slices? Why is it important to know how many slices of pizza there are in a pizza? It's our central angle, right? Okay, so what did we say for slices of pizza? 8 slices of pizza, right? Okay, so what is this angle in degrees? 45? Okay, would we agree that that's 45 degrees? Yes? But, going back to yours, theta has to be in radians. So what is 45 degrees in radians? Anybody? 45 degrees in radians. It is pi over 4 radians. Okay? So then, now we can use S equals R theta, because we know that the radius is 14. We know that theta is pi over 4. So that gives me, my arc length there is 7 pi over 2 inches. So my perimeter is that agreed. Okay. Now, the other one is, what's the area? Jackie? Pi r squared is the area of a circle, right? So that's going to be pi times 14 squared. The total area of our pizza is 196 pi square inches. Agree? But how much do we have of that? 1/8. Let's see, so 196 over 8. Let's see, both can be divided by 4. So that goes to 2. That goes to 4d9. Yeah. Agree? Good times. Okay. Mrs. Hill is cruising on her new electric scooter at a maximum speed of 15.5 miles per hour around the mean streets of Wausau. At this speed, how many revolutions per minute are the 8.5-inch diameter wheels rotating at? Okay, I love it. Okay? So it told us a starting speed or distance or something along those lines, correct? Okay. What's our starting value? 15.5 miles per hour. The label here is actually relatively important also. Okay? So we started out at 15.5 miles per hour. It also told us what we want to get it into. What do we want to get it into? Revolutions per minute. Okay? So we want to get it into revolutions per minute. So that means we're going to keep factor labeling until we've got revolutions on the top and minutes on the bottom. Okay? What do you want to do first? Miles first? Okay. All right, we'll deal with miles first. Okay. So this is an inch, so I mean I got to get it down to an inch, correct? So 1 mile is what? Remember, there is a stuff you should know board. 5,280 feet.
Yep.
Next. 12 inches over 1 foot. So now I'm in inches per hour. Diameter over inch. What is the radius of our circle? 4.25. How'd you come up with 4.25? 8.5 by divided by 2, because it's a diameter, so half of it's the radius. Okay? So then, a radius is a radian, right? Burn that in your brain. A radius is a radian. Okay? When you go to sleep at night, tell yourself a radius is a radian. And then say goodnight to yourself. Okay? Now I'm in radians per hour. I wanted to get it into revolutions per minute yet. What's my next one? AK, what are you confused about before we go on? So what are you confused about? Okay. Where'd the green fraction come from then? Explain it to me. I'm confused. I said, where'd the green fraction come from then? Because I'm confused.
Well, it's the bottom one.
Of the wheels. Yeah. Yeah. One revolution over 2 pi radians?
Yeah, 1 hour over a minute. So 1 hour over 60 minutes.
Because we still had hours sitting way over here yet. What is my labels now? What are my remaining labels? I got revolutions and I got minutes, right? Is that what I want it to be in? Yes, that's what I want it to be in. So we've got 15.5, 5,280, and 12 on the top. We've got 4.25, we've got 2 pi, and we've got 60 on the bottom. Find me the revolutions per minute. Concur? Questions, comments, concerns, clarifications? So the belt on an electric motor connects metal wheels with radii of 2 inches and 5 inches. The rotational speed of the larger wheel is 120 revolutions per minute. Okay? So we have 3, I think it's just 3 questions for this one. Yep, 3 questions for this one. Okay? First question is the angular speed of the larger wheel. Well, what is the current speed of the larger wheel? Kicker is it's in revolutions per minute, right? Okay, so it's 120 revolutions per minute. We want it in radians per second. Okay, go. Agree with 4 pi radians per second.
You have to leave it in that. Can you put it in a decimal? Like, which answer would you?
I love 4 pi. You can't get more exact than 4 pi.
But on the test, you guys said you would clarify, right?
Yep.
Okay.
You were right.
Yeah. 2 times 2 is 4. Yes.
Because we have nothing to do with radii yet. Because we had said that the rotational speed of the larger wheel is 120, and it's asking us for the angular speed of the larger wheel. Okay. We'll get to radii here momentarily. Okay. Now, in terms of this belt, we're going to use the chain on the bike because I can explain it better visually with the chain. So here's the big belt, or here's the big wheel. Here's the small wheel. You can barely see it behind the frame, but so there's that. Okay? So then it's spinning. Are they spinning at the same rate? No, because they're not the same size, right? What is spinning at a constant rate between those two, though? The belt. The belt cannot be faster as it's going around the big pulley as it is the little pulley. The belt is all moving at one speed. Okay? So if you are going to go from one pulley to another, they have to be connected with something, and that is linearly moving at one speed. That's how you go back and forth between pulleys. You got to find the linear speed of what's connecting them. Okay? Which is why here in number 2, we asked you to find the linear speed in inches per second of the belt. Well, I know from the last problem that the angular speed of that pulley is 4 pi radians per second. Okay? It won't be the last time I run this chair.
That's how you do that.
It's the third time today. Yeah. Please pay attention. Okay? Now, are we on the larger or are we on the smaller pulley? We're on the large one, so that means I'm using the 5-inch radius. Because that's the radius of the larger one. Okay? So the speed of the belt is 20 pi inches per second. What's up?
Is the cheat sheet on the back of the board gonna be on there for the test?
It's going to be on the back of the board for the test, yes.
It will say there?
I think so.
I'm asking hypothetical, even though it's not hypothetical. So I'm gonna have to take the test on Monday. Do I get a cheat sheet that says that?
No,
Oh, okay.
because you won't be taking it in here.
Yeah, thought I'd ask.
Okay, so now we have the speed of the belt, yes? Okay, so now it's asking us for the angular speed of the smaller wheel. Well, again, I'm building off of what I had before. The belt, which is connecting the two, is moving at 20 pi inches per second. So as this, the chain here, the chain is moving at 20 pi inches per second around this pulley, and as it's going around the smaller pulley also. Okay? What? Because now we have the speed of what it's going. Okay? So now, what did we say that the radius of the smaller one was? 2?
Yeah.
2 inches. Okay? So now, the smaller pulley has a 2-inch radius. So it is traveling at 10 pi radians per second. The two wheels, or the two pulleys, if you will, are not traveling at the same angular speed. They're traveling at the same linear speed, and they would be traveling at the same angular speed if they were the same size. But because they're different, the smaller one has to spin faster to keep up.
So if we were to get a bigger answer for the smaller, or for the larger, we would know we're wrong.
Correct, because it spins slower to go the same speed. Okay, one more for you. I think there's only 2 on this one. Let me just scroll and see. Yep, just 2. Okay, go for it. 4-inch diameter pulley on an electric motor runs at 1,450 revolutions per minute. It is connected by a belt to a 9-inch diameter pulley on the saw arbor. Find the angular speed of each pulley. All right, so we know that the small one is going at 1,450 revolutions per minute. We want it in radians per minute. Well, that means 1 revolution is 2 pi radians. So the small one is at what would that be? 2,900? Yeah, it is.
2,900 pi.
Yeah.
You just didn't put it
Oh,
into
I didn't hear the pie. I just heard the 2,900.
Mm-hmm.
How do you know that's a small one if there's like...
Because it told me up at the top, a 4-inch diameter pulley on an electric motor runs at 100 or 1,450 revolutions per minute.
Oh, well, we don't know the revolutions per minute for the...
Correct. Okay. So now for the big one,
take that time, right? And then you have to put it with the 9-inch.
So we know that the small one is spinning at 2900 pi radians per minute, right? Which would then be 5,800 pi inches per minute, correct? Because that's the radius of the small one. So now I got the linear speed of the belt. Couldn't see if it was a belt or a chain. I had to reread the problem.
Oh, yes.
Because that's the only speed that we know. So we gotta get there. Okay, so now we got the speed of the belt. So now I can transfer that over to radians of the big one. So then that's going to be what's that going to be? Phew, excuse me. When I do what? I did the fraction. On my calculator, it came out 128 or 1288.8 repeating, and I do that 0.8 repeating as 8 ninths. So I went 1,288 times 9 plus 8 gets me 1160 or 11,600, and then I knew it was overnight.
Wait, why did we do for the big one? Why did we do 2 inches for 1 radian?
Because we had to get to the belt. 4-inch diameter, which means 2-inch radius.
Oh, radius equals the
Radius is a radian.
Say it a bunch of times. Forever.
I know, but then what did we do with the 9-inch?
That's why it's 4.5 inches.
Oh,
Okay. Speed of the saw. So that's the end one, or the big wheel, in revolutions per minute. So we had it in radians per minute, and then we want it in revolutions per minute. So then that's going to be 2 pi radians is 1 revolution. So the pi's cancel, and then 11,600 gets divided by 2, and so then that's going to be 5,800 divided by 9. Let me show you. Pi's cancel out. 11,600 divided by 2 is 5,800. Yeah. I could see that you were like, okay, wait a second. How did that come out so nice and pretty? Okay. So good.
So it's 3 radian. No.
3 full rotations,
So 3
which would be 3 revolutions. No. Try that one. Give it a shot. What's our starting? What's our given? What do we got from the start? Nope. 3 revolutions. We spun the pedals 3 times. Okay. 1 revolution is how many radians? 2 pi. That sounds like a great place to go. Yes? Well, where are we at? What has spun 3 times?
The wheel.
No!
The change.
No!
The
The what? The pedal has spun 3 times. That's the only thing that's spun so far. Okay? So what is the radius of the pedal?
Wouldn't it be the 7.45?
7.45. So the chain has moved how far? This many inches, right? Okay? Which means the chain around the pedal has moved that many inches, which means the chain around the wheel sprocket has moved that many inches. Correct? So we're now on the wheel sprocket. Okay? So 2.52 inches is 1 radian of the wheel sprocket. Correct? Right? But there's this wheel that's on the same axle as the wheel sprocket. What's the radius of that wheel? What? 13.2 inches. What do we want our final answer to be in? Feet. What's What's the only thing we got left? Feet. Alright? So we've got 3, 2 pi, 7.45, 13.2 on the top. We've got 2.52 and 12 on the bottom. 3 times 2 times. How far did we go?
I probably should have wrong.
Yes, I did get that too. You were throwing out other numbers, or did I know what you're saying?
There were a lot of numbers getting thrown out about. Okay?
I would get confused.
Oh, that's it
Oh,
for math today.
wait, hold on.
Math's done.
Man, if you learn